Hi, good afternoon. I'm Paul Wheels. I'm founder of IoT North. I've got my good friend John Staveley with me. Hi, John. How are you doing?
All right. Yeah, really good here.
What have you been up to this month?
So I've just come back from Edinburgh, doing my IoT talk there, how to integrate Raspberry Pi with Azure IoT Hub. I sent out a mail to everyone in IoT North Scotland, and I met a few of them when I was up there, which was quite nice to meet some people and put names to faces. Been seeing a lot of content coming from Embedded World, which I couldn't do justice to, so I'm not even going to attempt. But one theme that came through was Matter and getting lots of devices talking to each other. So there's a single stack communication standard which enables all sorts of devices to communicate nicely. So I think that might be a good idea to get someone to do a talk on in future, if we can find someone.
Certainly, if anybody's out there that would like to come and talk on it, get in touch, which is info@iotnorth.uk. We will be taking questions. Please do ask them in the comments, whichever platform you're on. We are live on LinkedIn, YouTube, and our webinar StreamYard connection as well. We're very fortunate to have a great speaker here tonight with us, Adrian from the OpenVINO team in Intel. Hi, Adrian. How are you?
Hi, Paul. Hi, John. I'm fine, thanks.
So, Adrian, tell me a little bit about your role at Intel.
So now I am AI software evangelist, and it means that I go to conferences, go to meetups, and speak about OpenVINO. I teach people how to use OpenVINO, what OpenVINO is first, and then how to use it. And of course, I provide much technical content, writing blogs, providing notebooks, and so on. Everything for education.
Excellent. I mean, it sounds like a really cool, fun job. I mean, is it really work or is it not? Is it just fun?
No, sometimes, of course, it's a work, but sometimes it's just a fun, right? When I, for example, test Stable Diffusion or some generative AI like GPT models.
Mm-hmm. Excellent. I've been playing around with ChatGPT quite a lot. How about you, John? Have you been getting into it?
I had a dabble. I use GitHub Copilot a lot, so it writes code for me. That's more my sort of thing. So that's been very useful.
I've got to say, I'm seriously impressed by it. It's kind of what I always wanted a search engine to be, rather than just a list of links to go through to try and find out what I was really looking for as a source. The format and content and stuff is seriously impressive, if not a little bit scary. I was chatting with a friend of mine at a gig that I was at last week, I think it was, and he was saying that he'd actually got ChatGPT to write a contract for him for a customer. And he got his wife, who's a lawyer, to review it for him. And she gave him a gold star because it was so well written. He didn't have the heart to tell her.
Yeah, it's really useful for writing technical documentation on something.
Yeah. So it's really interesting to see how things progress with that and how much it's utilized and how much it can continue to be trusted. We'll see how that world goes. Adrian, so what do you like to do for fun?
For fun, I have one pet project which I implement in my free time. It's called OpenCV Image Viewer, and it's a plugin for JetBrains IDEs like PyCharm, so you can debug your computer vision applications without. You can see your images for computer vision applications without stopping the debugger. So yeah, this is my pet project, and I really have fun doing this in my free time.
And is that the favorite project that you've worked on, or does something really stand out to you?
Sorry, what do you mean?
Do you have a favorite project out of all your career so far? You know, is there a project that really stands out to you that you're the most proudest about?
I created an application for Android, for example, to take professional photo without leaving home. So, for example, you don't have to go to the photographer. You can go and take the professional photo at your home, just looking at some hints, like, for example, about the background, about your face, something like, your face is too big, please put your phone farther, or, for example, find the better background, which must be uniform and light. I mean, professional photos for IDs or passports.
Very cool. So tell us about your talk tonight.
So today I would like to introduce OpenVINO Toolkit, which is a toolkit for optimizing and deploying AI inference. And what's important, you don't have to buy any additional hardware to use OpenVINO. You can utilize the hardware you have here in your laptop. And even if you just use the CPU, your performance should be better than TensorFlow or Python. So I think this is like free lunch.
Wow, I mean, I'm hoping everybody can engage. Hey, if you're online today, as I can see a number of people are, please do say hello. I'd love to have you involved in this conversation. Adrian will answer questions at the end. Adrian, over to you. Thanks very much.
Thanks, Paul. So, yeah, let's start. Good. So my name is Adrian. I am AI software evangelist. We know that, so let's skip that part. And today I would like to tell you about the few lines of code you need to run faster real-time inference. And just one word more about me. I am part of a bigger team, so I am not alone at Intel. We are 5. We are team, and we cover different regions of the world, teaching people what OpenVINO is and how to use it. I have more than 5 years of experience in computer vision and deep learning. So if you want to talk to me about these topics, I am open as well. So first, let's talk about the challenge. Why you would need to use OpenVINO. So having your model trained is just half of the way, right? When it's ready, when it gives you high enough accuracy, the next step is deployment. And that's the problem, because how to deploy my great neural network? What are the choices? Of course, the first choice is GPU, right? This is nice choice. You have nice accelerator, you can put their heavy model, you have many frames per second, but at the same time, it's quite expensive, right? And generate much heat. So maybe CPU. In this case, it's low power device, low heat device, but at the same time, you have less frames per second. So what about other accelerators like XPU and X for unknown? XPU for and X for unknown, yes. And I mean any device which is able to run any AI algorithm. So what is the best choice? GPU, CPU, XPU? Maybe all of them, right? Why we need to decide right now? Let's use all we have here in our laptop, and let's leave the decision to the framework toolkit, something like that. Good. But if we use all of them, there are some questions appear, like how to get the best out of the hardware acceleration, then how to maintain code across different architectures. The same code, right? We would like to write once, run everywhere. And then how to get the most popular use cases and cutting edge AI running. So if we talk about using just one solution, one framework, one toolkit for deploying on any hardware and to deal with all these questions which appear, the solution is, in my opinion, OpenVINO. And OpenVINO, as I said, is open source toolkit for optimizing and deploying AI inference. And OpenVINO means open visual inference and neural network optimization. But it's not only for computer vision. It's also for NLP, audio processing, time forecasting, and many, many other applications. So let's start our OpenVINO developer journey. So let's assume you have your network in one of these frameworks: TensorFlow, Keras, PyTorch, ONNX, Caffe, MXNet, PaddlePaddle. Then you convert it to OpenVINO using one of our tools, And then you are able to run on any Intel's hardware like CPUs, Atom, Xeon, Core, GPUs. And when I say GPU, I mean this GPU already integrated into your CPU, like Intel HD graphics, Intel Iris graphics. But also I mean discrete GPU cards Intel launched last year. I mean Arc series or Flex series as well. Flex is for servers, for example. Or you can also run on VPU. VPU means Visual Processing Unit, as for example is that kind of device. This one is Neural Compute Stick 2, is a USB external acceleration. So if you plug into your USB port, you have external acceleration and you are not using any other resources. And of course, you can run off FPGA using FPGA AI suite. And it works on any operating system, Windows, Linux, Mac. So if you want to use OpenVINO, you need to follow 3 simple steps. Step 1, installation. And to download OpenVINO and install OpenVINO, you can scan this QR code. You will go to the selector tool when you can click your configuration and the tool will tell you what is the best way to install OpenVINO in your case. Of course, there are many ways to install OpenVINO. apt from Ubuntu, YAM from Red Hat or Fedora. You can also use Docker or Anaconda. But I think most people doing AI are Python developers, right? So in that case, I think the easiest way to install OpenVINO is pip. Pip install OpenVINO and pip install OpenVINO dev for development package. So the first step is OpenVINO installation. Now it's time for the second step. The second step means conversion and optimization. And we have 2 different tools in OpenVINO Toolkit. The first one, Model Optimizer and Neural Network Compression Framework. I will cover Neural Network Compression Framework in a while, so let's first talk about Model Optimizer. And Model Optimizer converts your model from your original framework, like PyTorch TensorFlow, to IR format, intermediate representation, which consists of 2 files, XML with architecture and binary file with weights and biases. But Model Optimizer not only converts your model, it also performs number of optimizations like graph pruning or fusing some operations together. So how to use OpenVINO Model Optimizer? Well, you can use this command line tool called MO and provide some parameters, especially path to your model. Okay, this means that you will get the same graph, processing graph, the same model, just in different format, but in the same precision. So we are not changing anything inside. We are just changing the number of operations, but the operations are exactly the same, right? If we fuse them, we are just using less instructions of CPU, but the result is exactly the same. So this is really important that we don't change any accuracy inside. But let's say that floating point 32 is not enough. The performance is not enough. We can go further. We can change the precision also to floating point 16. Of course, there can be very, very little accuracy drop, which is like, less than 0.1%, something like that. So if we can sacrifice just a very, very little bit of accuracy, we will get the better performance. And of course, to convert to floating point 16, we need to add this flag compressed to floating point 16. But this is command line. Since the last version of OpenVINO, the latest one, 22.3, we have a model optimizer Python API, so we can do the same in pure Python code. So you don't need to use any command line. You can just do the same in Python. So you just need to use convert model function and provide the same parameters you did before. And you will get Python object, of course, instead of model saved on disk. And I mentioned that the product of model optimizer is intermediate representation. So from this to this, much simpler, much faster to run the inference. And it was model optimizer. Now it's time to talk about neural network compression framework, NNCF in short. And NNCF is another optimization compression tool from OpenVINO Toolkit. And it's able to do, for example, quantization, post-training quantization, quantization-aware training, mixed precision quantization, but also filter pruning, binarization, and sparsity. So when you use NNCF, you will get the same model, but compressed, but optimized. And in that case, when you use quantization, you should expect a little accuracy drop. And now, when I say a little, I mean about 1%, something like that. So it's not very much, but performance is much, much better because we converted and quantized model from floating point 32 to int 8, which is, less precise and also faster to run the inference. So let's look at the code of NNCF. We know how to use model optimizer to convert the model, convert and optimize the model. And now let's look for the NNCF. So we need to import a few lines, a few packages like OpenVINO and NNCF. NNCF is a part of OpenVINO Toolkit, but it's a separate package. So you need to install it separately. And then we initialize OpenVINO, we read model. Now we provide some data loader. It could be PyTorch data loader, TensorFlow data loader, anything what can provide us the data. And then we need to define the function, transformation function. So for example, doing pre-processing, the pre-processing must be, of course, the same we do during training. And then create calibration dataset, consists of data loader and transformation function, and use quantization function, NNCF quantize, provide some arguments like model, calibration dataset, also some additional configuration. And we are done. The network now is quantized. We can use it. We can serialize it to disk and use it later. And if we look at accuracy difference before and after quantization, before it's blue color, after quantization is green. So we see about 0.004 or 0.008 of the difference between accuracy. So I think this is really nice because we lose just a little and the performance will be much, much better. I will show it. I will show you that at the end of this speech. And okay, so first step, OpenVINO installation. Second step, conversion and optimization via model optimizer or neural network compression framework. And now it's time for this third step, running inference using OpenVINO Runtime. And we just need a few lines of code. First, we import OpenVINO. Then we load our image or text or audio or any data we would like to infer on. Then we initialize OpenVINO by creating core object, read model from the disk in that case, then compile model for some specific device like CPU, get the handle to the output layer, and run the inference, giving the input and getting the output from the output layer. And that's all. That's all. 7 lines of code to run the inference when we have our model already converted with Model Optimizer. But it's not mandatory to convert our model. If you use one of these frameworks like TensorFlow or ONNX or PaddlePaddle, you can load your model directly to OpenVINO without any conversion. The conversion step will be done automatically for you just in the runtime. So it's nice, right? You don't need to think about it. You don't need to use any separate command. You don't need to write any additional code. Just load your model. Once again, TensorFlow, ONNX, PaddlePaddle. For now, of course, we are working on to support more frameworks, and then run the inference. Okay, but there is natural question. If we can compile for CPU, what else device can we put in that function? And of course, let's start with CPU once again. So we support Intel CPUs like Atom, low power, Core, what you have in your PC, and Xeon, what you have in your server. We also support GPUs, and the GPU means GPUs integrated into your CPU, like HD graphics, Iris graphics, and so on, but also discrete GPU cards, Arc series, Flex series, and so on. Then, if you would like to run on this device, Neural Compute Stick 2, you need to put here Myriad. And what is the best device? What is our recommendation? CPU, GPU, Myriad? No, there is one more device, a virtual device called Auto. And this is our recommendation because Auto will choose the best device for you based on your hints you provide, and will handle the exec logics on multiple devices. So Auto will care about anything. If you know that you would like to save some resources and you want to run only on GPU, it's okay, put GPU. But if you don't know, or if you would like to use all devices and you don't want to think, configure, and so on, just use Auto. Auto is our recommendation, and we really support Auto much, and we develop it very much as well. And using Auto, you can provide also performance hints. So let's say that you care about latency, right? You have application that you get frame by frame, and you would like to get the results as soon as possible. So in that case, Auto will select one device from a candidate hardware device list with many processing units, for example, and we'll create one single stream to infer one by one. So you are sure that the results will appear ASAP. How to do it? If you provide device name called Auto, you can also add some parameter called config, and then specify that performance hint equals latency. But let's say that you don't care about latency. Let's say that you care about throughput. You would like to process as many frames as possible in 1 second. So in that case, Auto will select one device from candidate hardware list and will create multiple streams to infer concurrently with auto batching. And how to use throughput mode? Once again, provide additional config and a performance hint equals throughput. There is one more mode in OpenVINO. It's called cumulative throughput, and it works like the following. Auto will select many devices, not just one, many devices from hardware device list, and of course will create multiple streams to infer concurrently with auto batching, and will preserve device priority. How to use it? The same like usual, just provide performance hint equals cumulative throughput. But I mentioned that if you use throughput, if you use cumulative throughput, there is auto batching feature. So let's look at it. Auto batching means that let's assume that the optimal size of batch for some specific device, let's say CPU, is 4, right? So if we have 4 inputs, 4 frames, 4 sentences, this is the best what we can get from the performance. So auto batching will wait for the full batch, and when it's ready, it will pass to the inference for the second batch. We are waiting for 4 inputs and then pass to the inference. And once again, the same. So how to use auto batching? It's enabled by default. If you just used throughput or cumulative throughput, you don't have to do anything else. But let's look also at the code. Let's import OpenVINO, let's initialize it. Then we implicitly trigger auto batching in throughput mode. It doesn't have to be auto, it can be also GPU device to use auto batching. No problem at all. Then how to specify the optimal number of infer requests? Well, we can get that property from the model itself, and then put the value to the config and compile model with that config. And if we know that we would like to save some resources, or we know that for this specific device, 4 inputs is exactly what it needs, we can just specify it explicitly. So instead of some auto optimal number of infer requests, we can specify value equals 4. Good. So the first half of the way is training, right? But if we add software and hardware, we have successful deployment, and now we are ready for the production. Now we can earn money providing our services. Good. There is one more important feature of OpenVINO. I think it's important. It's called dynamic shapes. And let's think about the situation that you don't work on images, you work with natural language, so with text or audio, and your inputs have different lengths, right? This is usual because there are different sentences with different length. So the usual approach is using static shape. So you just add padding at the end, for example, with the zeros, to fit neural network input size. If your input is longer than fixed size of your network, you need to split your input into parts and run inference one by one. But if you use dynamic shapes, you don't need to do it anymore. You can use that feature, and it will resize the network automatically based on your hints. Based on your input, not hints. So you don't have to do it yourself. I think this is really convenient way to deal with different inputs. And how to use dynamic shape in the code? Well, the beginning is exactly the same. We need to import OpenVINO. We need to load text in this case, but it can be any data. Initialize OpenVINO, read model from disk, and now it's time to get handle to the input layer, read the shape of the input layer, then assign -1 in one of the dimensions. And -1 means unknown. It means dynamic. So if we assign -1, it means it will be resized automatically by OpenVINO. Of course, we can specify lower and upper bounds, like, for example, 1 and 384, if we know these bounds. And I recommend to do it if you know them, because it will save some memory as the bounds are specified. And then we reshape the model and compile it for some device like CPU. And maybe here you are wondering, can I use GPU, Myriad, Auto as well? Unfortunately, no. For now, we support CPU only. We are working on this. In the next version of OpenVINO, in 2-3 months, GPU should be supported. But for now, just today, you can use CPU only. Okay, but if we talk about educational content, we created OpenVINO Notebooks repository where we have more than 60 different demos. Stable Diffusion, GPT, YOLO, Clips, Object Detection, many, many more. I'm going to show you some examples right now. For example, we have there Object Detection. Pose Estimation. Action Classification. This is Paula. Paula is my teammate. She is responsible for US region. Style Transfer. And this is Anisha. Anisha responsible for India market. OCR. And this is my last teammate, Juo, responsible for China region. But of course, these are basics, right? Object detection, pose estimation, image classification, and so on. They are very popular still, but we also have some hot topics like Stable Diffusion. This is nice. I try it. It works faster using OpenVINO, right? I used my CPU to get the image in, I don't remember exactly, but it was like 1 minute or 2 minutes, something like that. Of course, it depends on your parameters, like because you can specify how many iterations you would like to use to generate the image. But in my case, I think it was 1 or 2 minutes. But of course, if you use DGPU, I mean Flex series, because I tested on discrete Flex GPU, I did it the image in 10 seconds, 15, something like that. It was really, really fast. So yeah, it was a lot of fun. So you prompt, you type your prompt, and then after 15 seconds, you have the image. And another hot topic, YOLO v5, YOLO v8. We also have this in our notebooks, right? So you can learn how to convert YOLO v8 to OpenVINO to even have faster inference. And yeah, I'm talking about this, about that, and so on. I think now is the time for the most interesting and exciting part of this presentation. Let's run the real code. I'm gonna show you two of our notebooks we have in our repository. So first, the repository is here. So if you go to GitHub and to OpenVINO Toolkit organization, there is OpenVINO Notebooks. And as I said, there are more than 60 different notebooks teaching you different aspects of OpenVINO. And I'm going to run 2 of them right now. So first, live object detection. This is very simple case. It's very interactive. I'm going to show you how to run OpenVINO, and let me zoom in a little bit, and I'm gonna explain what I am using on the way. So first, we need to import some packages, right? Especially OpenVINO here and OpenVINO TensorFlow frontend. Then we download our model, and our model is hosted somewhere in the internet. So we specify the URL for that model, and we are downloading here and extracting. So after this step, the model is downloaded and extracted. But the model is in TensorFlow format. So the next step, we have two choices, right? We can use TensorFlow frontend directly on OpenVINO, or we can use Model Optimizer in command line or in pure Python code to convert it to OpenVINO. We decided to go with Model Optimize here because it must be some learning for you. So we are showing how to convert that model using Model Optimizer. So we use Model Optimizer command line tool. In that case, we provide some parameters like input model. I mean, of course, this is path to TensorFlow model, model name that we would like to compress to floating point 16, for example, and some additional configs we need to provide for object detection model. And after that, let's run the code. Maybe it can run in the background. And then we need to, of course, initialize OpenVINO, read model from disk, compile model for CPU, and get input-output nodes, and input size. Then we specify classes we would like to detect. The model was trained on Coco dataset, so these are classes from Coco. And we specify colors for these classes. Then function to post-processing results, like creating boxes around objects, doing non-maximum suppression to get rid of many overlapping entities, and then return a label, score, and box for every object. Then function to draw boxes on the image. It's very simple function using OpenCV. And then main processing function, so creating video player to stream our webcam or video file. Then we get frame by frame, resize it to fit a neural network input size, creating batch size of image, batch of images of size 1. Then doing inference with time measurement, post-processing results, draw boxes on the image, calculating mean processing time, and put that information on the image, average in the inference time, and showing everything directly in this notebook. So yeah, it works. Good. As you can see, everything works smoothly. I can show my phone works, class also. But what's important? The performance is important. Look here. We have 9.6 milliseconds per one frame, what gives us 102 frames per second. It's faster than real time, right? And when I say real time, I mean, of course, 30 frames per second. So it means that using that model and OpenVINO, we are able to process 3 different streams simultaneously, and all of them in real time. Good, but it's not the end. Let's see what performance we will get if we change this device to GPU. So the compilation time is a little bit longer, right? Because we need to compile OpenCL kernels and so on, but it's done. It's after 5 seconds, 7 seconds, it's done. And then I'm going back to the bottom and running this once again. So the final performance was 105 frames per second. And if we run it once again, we have 120 frames per second. Nice, just changing one line of code. And I didn't buy any additional hardware meanwhile, right? I am just using the hardware I have here, the integrated GPU, which is inside this CPU I have here. It's nice. I could say this is free lunch. I already have this hardware. Okay, but let's also test our recommended solution, auto device. And yeah, let me run it once again and see what performance we have right now. And yeah, it's a little bit faster than GPU because it's using some optimization under the hood also. So 126 frames per second. So yeah, this is nice, right? I really like that because it's, as I said, it's like a free lunch. Okay, and if you would like to try it at home, no problem. You can run it with your webcam. You can run with video file. The performance should be absolutely the same. It works with both streams. Good. This was the first notebook I wanted to show you to prove you that OpenVINO is really fast. And then let's go to the quantization part. So I already presented NNCF. I already told you about dynamic shapes and about quantization. So we are going to use all of them in this notebook. So I'm going to run the notebook right now. We would need to wait a little bit because it takes more time than the previous one. So I'm going to scroll down and explain on the way. We need to import some packages, of course, OpenVINO here. We are importing a model optimizer because we are going to use conversion function directly in Python. So we are not going to use command line tool like in 401, like in Object Detection Notebook. Then we also import NNCF. Then we specify some parameters like URL to model. Model is downloaded from internet also. So we download this model, we extract it, and then we need to export it to ONNX. Because I didn't mention so far, but OpenVINO is not able to run PyTorch models and convert PyTorch models directly. We are working on this right now, but if we talk today, you first need to export your PyTorch model to ONNX first, and then ONNX to OpenVINO. I know it's not the most convenient way to do it, but no worries. We are working. I promise you, we are working on this, and it will be available in one of the future releases. So we are converting to exporting to ONNX, then converting to OpenVINO IR format. This ONNX model. So now we are using conversion function instead of command line. Then we prepare a data set, creating data loader ourselves. And we are going to use NNCF. So we need to initialize OpenVINO, read model, define transformation function, create calibration data set. We'll get data from this, applying this transformation function, and then quantize our network to int8 precision. And as you could see, it's still running, so we need to wait for this. So let's go further. I'm going to explain the next steps. Meanwhile, it will finish. Okay, then when it's quantized, we can serialize it to the disk. So it means we are just saving to the disk the model. In the future, you can just read the quantized model. You don't have to do it once again. And then we are initializing OpenVINO once again, read model, this quantized model in this case, because previous model was floating point 32. Now we are reading int8 model, assigning -1 to one of the dimensions. It means we will use dynamic shapes because we are working with text. And then we are just checking if the accuracy, if the model performs good, like, you know, if these two sentences mean the same, they are, so they do, so it's okay. Then we validate our models before quantization and after quantization. And this is rather unexpected that we have exactly the same F1 score in this case. It can be accuracy, it can be F1 score, doesn't matter. But this is not usual, right? We should expect a little accuracy drop. If we see the same F1 score or accuracy, we are just lucky. So we are happy, right? We like to be lucky. And then the most important part of this notebook, something what I want to show you. We are going to measure the performance of PyTorch model on CPU, performance of this PyTorch model converted to OpenVINO, but in floating point 32 format, so nothing changed inside, right? It's just in new format with some optimizations, not changing anything in the processing graph. And then int8 model, so after quantization, PyTorch, floating point 32 OpenVINO, int8 OpenVINO. Each of them on CPU. And the results are as the following. Using PyTorch, we got 3.3 sentences per second. It's good, yeah, it's enough. But if we convert the model to OpenVINO, this specific model, this particular model, we have 12.2. So it's about 4 times faster than PyTorch. And if we additionally quantize the network to int8, we get 28.3 sentences per second, which is more than 2 times faster than floating point 32. And comparing to PyTorch model, of course, is more than 7 times faster. So this is nice because we can use many streams simultaneously, right? We don't have to handle just one user. We can handle many users at once because we are able to do it because we are using OpenVINO and sacrificing just a little of accuracy. Good. That's what I wanted to show you right now. If you want to run it, you can absolutely, you can run. Yeah, there is, oh, sorry, I forgot. There is one important question. Does it mean that this model will be 7 times faster always? Or does it mean that all models will be 7 times faster in OpenVINO? Of course, not. Absolutely no. It depends on the model and it depends on the hardware you have, right? I can tell you that this model on this hardware I have here, it's 7 times faster. But in case of your model, in case of your hardware you have, you need to check it yourself. I think it should be, no, I think it should be faster than PyTorch or TensorFlow or Keras or ONNX, but you need to check how much. Good. Let's go back to our presentation before we jump into question section. I still have a few slides, just a few slides, so no worries. The OpenVINO Notebooks repository, how to use it. You need to clone the repository, create the environment, install requirements, and launch the notebooks, and you can do it at your home. So I really recommend you to try and to see what performance you have in your computer. But maybe you are just wondering, is OpenVINO like new thing? We are looking for testers or something like that. No, OpenVINO was already adopted by many companies from IT industry. Maybe you recognize some of them here. I, for example, recognize Accenture or HP or AD-Link and something like that. But if you still don't believe me, I can show you our graph of downloads. We crossed 1 million of downloads of OpenVINO in the history, just 2 or 3 weeks ago. And as you could see on this, this is from pip trends, so it's counting our pip downloads. We have about 4,500 downloads per day, so it's quite popular, and it's used by other people, by AI developers. But at Intel, we don't have only OpenVINO. We also contribute to other libraries, other frameworks like TensorFlow, PyTorch. So we have our extensions, Intel extensions for PyTorch, Intel extension for TensorFlow. We also contribute to NumPy, to SciPy, to be sure that your performance is great on Intel hardware. So if you are not on the stage of deploying, if you are on the stage of modeling data or creating your networks, you can look at our other libraries, at our extensions to these libraries. And my main takeaways for today are: you don't have to buy any additional hardware to use OpenVINO. You can utilize the hardware you have here. And even if you just use CPU only, without iGPU, without anything else, your performance should be really, really fast, and should be faster than TensorFlow or PyTorch. And third, the best way to learn OpenVINO is visiting and trying OpenVINO notebooks. But don't just believe me. Try it yourself and see the performance you have. And if you want to connect with us, absolutely we recommend to do so. You can, if you scan this QR code, you can find many useful materials there, like OpenVINO blog, our LinkedIn accounts. I really recommend you to connect to me and others, also to be up to date, because I'm posting about new features, about new releases of OpenVINO. I also post how much fun you have working with Stable Diffusion in OpenVINO or GPT-like models. That's all from my side. I think it's time for questions. If you have any questions after this event, don't hesitate to reach out to me on LinkedIn, or you can drop me an email. I always respond, so no worries.
Great talk. I'm just going to bring John in as well. Oh, John, where you at? There you are. There we go. We've got a few questions up here. John, do you have any questions that you want to ask before I start to roll them out?
Yeah, I had a few. So following on from Vishnu's question, does OpenVINO work as middleware like ROS? Not familiar with ROS, but if you could answer that one first.
Yeah, I think so. It's not well, it's not low-level library, right? So it's not like one API that you only use some primitives, or you use only some functions to do like multiplication. No, it's higher level. So you use entire model at once, right? The entire model is a function you use. So if we can we call it middleware? Yes, we can, but at the same time, it's like a high-level library.
Cool. So my question was, so if I install it as a Docker container, can I just make calls into it, like use it as an API, or have I got to have Python or TensorFlow running in there as well to make use of it?
So you wanna use it in Docker container, right? And
Yeah.
you wanna
make calls into it. So rather than having like that being my entire development environment, like having Python and TensorFlow installed.
okay, I know what you mean. I think that the best answer for that is OVMS. It's OpenVINO Model Server. So it's a Docker container. You just start it. You just provide the path to your model, and it's serving the models for you. So you can connect via, REST API, and you have results sent to you by OVMS.
Okay, cool. Riza Mahmoudi was asking, could you share the slides?
Yes, absolutely. I don't have any problem with that.
Okay, so Riza, if you follow our Twitter account, IoT North U, we'll tweet them out tomorrow for you. And there's some more questions. Does it work with ESP32? Mark Jones was asking.
I need to know what is ESP in that case.
ESP32 is like a small embedded device, like smaller than Arduino.
Oh, okay. So if we talk about embedded devices, there must be Intel hardware, like Intel CPU, for example, Atom. I am not sure if there is any Intel CPU, but for example, you can try with that, external device. If there is a USB port, I don't know. I know that you can plug it to Raspberry Pi. If you can plug it there through USB port, you can use this device.
Okay.
And
does that
OpenVINO.
device have a camera on it or an audio sensor or something like that?
No, this is just accelerator, external accelerator.
Right. Okay. Right. So my follow-on question from that, I think you've already answered it though. Does Auto recommend non-Intel devices? And I think what you're saying is no, it has to be an Intel device.
Yes, we support also ARM devices, but this is through OpenVINO contrib repository, and so it's supported by community, right? So of course we are focused on Intel's hardware, but also there is community support for ARM plugin. So you can look at GitHub OpenVINO contrib repository. And I try it to run on Raspberry Pi. I try it to run it on Android. It works, but the performance is not as good as for Intel hardware.
Okay, cool. Reza Mahmoudi was asking, can OpenVINO be used in C++ for inference?
Absolutely. OpenVINO is written as C++, so has Python wrappers. But of course, you can use C++ also. You just check out our documentation. There are C++ snippets.
Cool. So if I'm using OpenVINO notebooks, I really love the concept. I'm a fan of Jupyter notebooks. So it's a really powerful idea. Is there like some examples, like ready-made things I can just play with and tweak, or have I got to come with OpenVINO notebooks with my own models and then work with them that way?
Yeah, I think so. There are many different notebooks, so you can learn features like asynchronous processing, which I didn't cover today. You can learn about how to convert object detection model. You can learn how to convert semantic segmentation model, how to deal with stable diffusion, GPT-like models, how to use pre-post processing API. So you can add your pre-processing and post-processing steps inside graph, right? You can join all together and create and run everything on GPU, for example, using OpenVINO.
Great, fantastic.
Hey, we're sadly out of time now. Adrian, absolutely fantastic talk. Really appreciate it. John, thanks for leading the questions there, as always. John, who have we got for May?
So May, we've got Andrew Blant speaking on getting insight from anything using IoT to make decisions. So when you've got streams of data coming in from all over the place, how are you going to process them and get meaningful insights out of them? So it should be a very useful talk to our membership.
Excellent. Looking forward to that one. On that, thanks everybody for joining us, and good night.
Good night.
Thank you.
He says Stalin looking for his outro. Thanks, Adrian.
Thank you guys for having me.